Welcome back to another explainer, where we take these massive technical breakthroughs in AI and really break them down so you can actually understand and use them. Today, we're diving into something huge, the evolution of iterative RAG. To really get why this is such a game changer, I want you to imagine a crime scene for a second, right? A detective walks in, sweeps the room with a flashlight, spots a single muddy footprint near the window, and just immediately yells out, "Case solved, arrest the gardener." I mean, it sounds absolutely ridiculous. No real detective operates that way. But the crazy thing is, until very recently, that one-shot approach is exactly how our most advanced AI retrieval systems were operating. They'd find one clue and instantly close the case.
Case solved, wrong conclusion. Because, look, if a detective finds a single clue and just stops looking, they're going to get it wrong almost every single time. Real investigations take work. You find a clue, use that clue to go interview a witness, you use that witness testimony to find new evidence, and you are constantly revising your working hypothesis. But that ridiculous scenario of the terrible one-clue detective, that is exactly how classic RAG, Retrieval Augmented Generation, actually operates under the hood. You give it a prompt, and it searches the database exactly once, it retrieves the documents exactly once, and it generates an answer exactly once. One search, one shot, case closed.
When you stack classic RAG up against a real investigation, the glaring difference is pretty obvious. Now, to be fair to classic RAG, if you ask it a super simple, one-dimensional question, something like, "What is the capital of Japan?" that single retrieval works perfectly. It finds Tokyo, boom, you're done. But real-world reasoning, the kind of complex, messy problem-solving we actually need AI to do in enterprise business or medicine or research, it is never that simple. If you want true intelligence, knowledge retrieval literally cannot be a single isolated event. It has to be a continuous loop. It needs to be a dynamic conversation between the AI and the data. Section 1. The multi-hop reasoning shift.
Okay, so we've established that simple trivia questions are fine. But what happens when things get a little complicated? Why exactly does the classic RAG model completely break down when it's faced with the kind of layered, nuanced questions that you and I deal with every single day? Take a look at this question. Which scientist influenced the founder of the company that created the iPhone? If you throw this at a classic RAG system, it absolutely panics. Why? Because there is no single document anywhere in any database titled "The Scientist Who Influenced the iPhone Creator's Company Founder." That just doesn't exist. The answer is deeply buried across entirely separate, disconnected pieces of information. One single search simply cannot retrieve this answer. The system is structurally blind to it. And this brilliantly illustrates what researchers call multi-hop reasoning. To solve that question we just looked at, the AI actually has to go on a bit of a journey. Step 1, it first has to figure out who created the iPhone, which is Apple. Step 2, it then has to ask, okay, well, who founded that company? Steve Jobs. Step 3, finally, it must ask, who influenced Steve Jobs? You see what's happening? Each answer literally unlocks the very next question. It's a chain of logic. You absolutely cannot make hop 3 until you've successfully landed hop 2. You know, what's really fascinating here is how closely this mirrors human cognition. Just think about how you research something you don't know. You don't just type one magic phrase into Google and instantly understand the whole shebang. You search, you read a few articles, you discover some new term you've never heard of before. And then what do? You search again using that new term. You build your understanding gradually through iteration. Researchers realized that if AI was ever going to solve highly complex problems, it needed this exact same multi-hop ability. It needed to iterate.
Section 2. A new technical control flow.
Recognizing the problem is one thing, right? But how do you actually build a system that thinks in loops instead of straight lines? Well, this required a massive fundamental shift in the AI's underlying architecture. And here is the breakthrough definition we need to talk about: Iterative RAG. This is a system that actively analyzes the learned information after every single retrieval to decide what missing information must be searched for next. This is a total game changer. For the first time, AI shifted from passively consuming documents, just reading whatever was blindly handed to it, to dynamically investigating a problem. Instead of performing one search, the system performs many. And the missing information from search number 1, that becomes the precise query for search number 2. Let's consider another really complex scenario. Which university did the advisor of researcher X attend? Again, the answer is totally scattered. The AI needs one completely isolated document just to identify who the advisor even is, and then a totally separate, unconnected document, maybe some old, obscure alumni newsletter, to figure out where that specific advisor went to school. With iterative RAG, the first retrieval grabs the name, and the second retrieval hunts down the education.
So the absolutely crucial point here is exactly how this technical control flow happens under the hood. The biggest technical innovation wasn't actually a better search engine, it was how the system orchestrates the data. The system now maintains a temporary working state between these search steps. Think of it like, actually, it's exactly like the AI keeping a scratch pad open on its desk. After every single search, new evidence gets added to the notepad. The AI's working understanding improves. Because of that, its future searches become incredibly precise. It acts exactly like a scientist, continually refining a hypothesis based on brand new data. It fundamentally remembers what it just learned and uses it to dig deeper.
And this builds into massive real-world value. Large enterprises absolutely love this. Why? Well, imagine a company with millions of technical manuals, internal reports, and IT support tickets. The answer to a critical business question might actually rely on connecting a fact from a 2018 HR policy to a totally separate 2023 engineering report. Iterative RAG's dynamic knowledge graph exploration reliably connects these scattered facts across entirely different internal departments. It synthesizes years of data. And honestly, the best part? Because it meticulously gathers this step-by-step evidence, it results in drastically fewer AI hallucinations. It's literally showing its math.
Section 3, the efficiency trade-off. But, as with all incredible engineering breakthroughs, every solution creates a brand new problem. We've built this brilliant, iterative, detective-like loop, but being a meticulous detective comes at a steep price. When you directly compare the efficiency of both systems, the trade-off is painfully obvious. Classic RAG might fail at complex tasks, sure, but it is incredibly fast and incredibly cheap. One search means low latency and low cost. Iterative RAG, on the other hand, solves those incredibly complex tasks, but it requires multiple searches. That means high cost and high latency. Every single time the model loops, it burns computing power. If you have infinite search loops, your GPU usage spikes into the stratosphere, your server costs skyrocket, and the user is just left staring at a spinning loading screen, waiting for the AI to finish its deep dive investigation.
And that brings us to the number 5. Imagine a user asking that simple question again. What is the capital of Japan? But this time, they're using an iterative RAG system. The system might perform 5 incredibly expensive retrievals for a question that really only required one. Why? Because it's a hammer that treats everything like a nail. It gets stuck in an investigative loop, repeatedly searching for more context when it already has the answer sitting right in front of it. It is phenomenally inefficient to overthink a simple problem. Section 4. The birth of reflection. So you can see how researchers suddenly had a massive efficiency problem on their hands. How on earth do you keep the brilliant investigative powers of iterative RAG without bankrupting yourself on server costs for simple questions? Well, the AI needed to stop blindly looping and start thinking about its own thinking. It needed an internal self-evaluation checklist. It needs to act like our detective pausing for a second to look in a mirror. Before initiating another expensive search, it needs to ask itself, is retrieval actually needed for this prompt? Is my current evidence already sufficient? And, crucially, will spending money on another search actually improve my answer, or am I just spinning my wheels here? The AI had to learn how to evaluate its own confidence. Which leaves us with this final, really provocative thought for this explainer. What if AI could accurately judge its own uncertainty? What if retrieval wasn't just a mandatory loop, but a conscious, carefully weighed decision? This exact self-critique is what eventually leads to the creation of self-RAG, a system that doesn't just search, but actively questions itself. But how exactly do you teach an AI to doubt itself? Well, that is a fascinating story for our next explainer. Thanks for joining me on this deep dive, and I will see you next time.